Welcome to a new video. In this video, we're going to be talking about logarithms. I'm planning to make it 8 videos, so I'll talk about logarithms in a deeper way and try to explain everything as much as I can. Let's take a look at the definition first. What is a logarithm? Logarithm is a function actually. And if you look at the definition, it says, suppose that f is a function which is defined from all positive real numbers to real numbers. That means the domain is positive real number, so we can give any positive real value to the x here, and the outcome can be positive real number or negative real number. And so in such a function, f of x is equal to a to the power of x. As you can see, this is exponential function. Then the inverse function of that exponential function is called a logarithm function. Here there is one thing that we need to consider, which is f of x is equal to a to the power of x, right? A should be any positive real number except 1. Okay, so a cannot be equal to 1, and we will see why it is in our upcoming videos. But at the beginning, we can just suppose it as it is. What is an inverse function? Function, we define f of 1 as 2. Okay, f of 4 as 5. So here, if f of 1 is 2, then f negative 1 of 2 is 1. Okay, and here, similarly, we can say that f of negative 1 of 5 is equal to 4. So let's say I have two sets. Okay, the first set is domain. Okay, this is a is domain, and b is the range, and that function is called f from a to b. So here, let's say we have we have 1, and we have 4 in the domain. In the range, we have 2 and 5. 1 goes to 2. F of 4 is 5. That means 4 goes to 5. If you look at the situation directly, we can say that f of 1 is 2. If you look at the situation from b to a, we can say that inverse function of f of 2 is 1. We can think the inverse function as you are looking at the situation from range to domain. You can explain the inverse function in this way. If the function is an exponential function, okay, like a to the power of x, right? This is an exponential function. A is, as I said, any positive real number except 1. So this function is called an exponential function, and the inverse function of this function is called a logarithm function. Basically, we can say that if f of x is equal to a to the power of x, and then its inverse is equal to log base a of x. Here a is base, okay? X is the number that we are taking the logarithm of. We will understand it better if you look at an example. Let's take a look at this example. In the base 4 of logarithm x is equal to 2, so in this case, what is x? Here, how we can think this expression is, take this 4 and bring it over here, so it's going to be 4, and then bring this 2 as a power. So it's going to be 4 to the power of 2. On the right is this, and this x, bring it as it is to the left. So x is 4 to the power of 2, if this is the case, of course, and then x is 4 times 4, which is 16. Let's take a look at another example. Logarithm in base 5x is equal to 7, if this is the case, and then what is x? Again, the same thing, okay? Bring this 5 here, 5, and then 7 comes as a power or as an exponent to the 5. And then just carry this x directly as it is to the down. So x is equal to 5 to the power of 7. Okay, let's take a look at this example. From the similar logic, okay, just bring it over that base to the right side, okay? So it's going to be x. And this 3 comes as a power to the x, so x cubed is equal to, so the right side is x cubed, and then just bring this 27 to the down as it is 27. So if 27 is equal to x cubed, and then 27 can be written as what? 3 to the power of 3. If 3 to the power of 3 is equal to x cubed, because we have 3 as a power to the both sides, so we will take the third root. Okay, let me write it here. 3 to the power of 3 is x cubed. Take the third root of both sides, and then this 3 comes out as 3 by just giving this 3 as a power, okay? So it comes out as 3, and then that x goes out as x also by giving this 3, which is its power. So x is 3 in this case. Number 4, in this question, again, the base is 2, and here we are taking the logarithm of x plus 6. So logarithm of x plus 6 in base 2 is 4, in this case, but is x. So the same idea, guys, take these 2 and then bring it over to the right side. It's gonna be 2 to the power of 4. And just x plus 6 comes as it is to the down, okay, just write it down. So 2 to the power of 4 is what? 2 times 2 times 2 times 2. There are 4 2's, and if you multiply them, you got 16, of course. So x plus 6 is 16. And of course, how are we gonna find x? Just send this 6 to the right sides, okay, make it negative. X is 16 minus 6. Some of you may ask, okay, how did you do that? I recommend you to take a look at my video, which is about shortcuts, okay, for those who don't know this. If this is the case, then if you subtract 6 from 16, you have 10, so x is 10 in this case. Now let's take a look at next example. In this question, again, we're taking the logarithm of 2x minus 1 in base 5, which is equal to 2. So in this case, what is the value of x? The same idea, guys. Let's bring this 5 to the right. So it's going to be 5 to the power of 2. Always this right side comes as a power, okay? And then this number always comes to the down as it is. So it's going to be 2x minus 1. So the left side is 2x minus 1, and the right side is, if you take the power of 5, then it's going to be 25, of course. And then just send this negative 1 to the right, because here it was negative 1 and now it becomes positive 1. And if this is the case, 2x is left over on the left, and the right is 25 plus 1, which is 26. If 2x is 26, just leave x alone. How? Divide both sides by 2, which is in front of x. These are gone, so x is alone right now. X is, if you divide 26 by 2, then you have 13. Okay, let's take a look at this example. Again, the same thing, guys. Here we have the base is x plus 1, and logarithm of 8 in base x plus 1 is equal to 3. So in this case, what is again the value of x? Again, the same idea, guys. The base is x plus 1, so just bring it over here. X plus 1 to the power of 3, which is equal to 8. Why? Because just bring this number as it is to the downside. And 8 is 2 to the power of 3, which is equal to x plus 1 to the power of 3. Again, we have the third power on the both sides, so we will take the third root of both sides. Here should be 3. Third root of both sides. Then on the left side, this 2 comes out as it is by just leaving its power, because the power of 2 and the root, they are same. So on the left we have 2. On the right we have x plus 1. Just leave x alone. How? Just send 1 to the other side. On the right here it is positive 1, and now it becomes negative 1. So 2 minus 1 is x. That means 1 is equal to x. So basically, I believe in this video we understand how to solve the logarithm questions. But these are easy questions. We will take a look at the features of logarithms in the upcoming videos, and we will go in a deeper way to understand the type of the questions in this topic. Thank you for watching, and hopefully see you in the next video.